Hello and welcome to another video on statistics, where today we're going to work through an example on regression, linear regression. We have previous videos in the playlist where we've already discussed everything. You've seen an example that we do with a hand calculator. Now we're still going to do this example by hand, but we're going to illustrate the convenience of using spreadsheets to just organize our information and our calculations a little bit better. We're not using the full functionality of the spreadsheet software, in this case Microsoft Excel. We're simply using it as a glorified calculator to illustrate its usefulness even in a basic sense. So the textbook that we're going to use for this example is Statistics for Psychology. Doesn't matter if that is not your prescribed textbook, just the one I have available to show on screen. We're going to look at page 535. Now it is number 17, but they all use this number 15's wording. Now we're not doing all of these, just the first few, but it gives you still an introduction to the basic idea. So we have 4 individuals. We're given a test of manual dexterity and anxiety. And we have some results here. And you'll see in my spreadsheet, I put some of those scores in. We want to draw the linear prediction rule, or the suggested rule, the least squares fit, for predicting anxiety from dexterity. So we want to investigate, this is our dexterity is our input. Does it predict anxiety scores, and what's the rule for that linear prediction? We want to draw the regression line. We want to get the equation, of course, y equals mx plus b, if you think about high school math. And we want to use that to calculate the predicted anxiety score for different dexterity values. And lastly, the standardized regression coefficient. And then we will stop it there. Now, in our number 17, we're doing 15, but we're adding an additional score set or pair of scores, dexterity 4 and anxiety 10. So everything else is the same. So firstly, let's visualize what's happening here with a graph. Now, using spreadsheet software makes graphing and visualization a little tidier, a little neater than doing it by hand. And we can definitely utilize that and take advantage of that. So we're going to insert. We click on insert here, a chart. We're going to look for a scatter plot, which is the one with the dots there, the one with no extra fancy lines. And that puts this graph space over here. Then I'm going to right click, select the data that I'm going to use. There are multiple ways of doing these things. I like to add here. You can give it a name. We can say anxiety versus dexterity or something like that. We have our X values, which is the dexterity scores, Y values, delete what's in there, and select the anxiety scores, click OK, click OK again. You see here, this was the outlier that we added from number 12, making things definitely a little less clear. But this could just be your data set, and you don't know that this was a late addition and an outlier. So we have to analyze this as it is. Let's just check the question again. Where's number 15 that is references? So determine the linear prediction rule. Oh, and then draw it. I drew it. I did a scatter plot early, so we'll hold off on drawing the actual line, let's calculate it first. So for that, we have our x values and our y values. We want to calculate the mean of the x values. So the formulas that I'm referencing here in this book is on page 505. Let's go there. 505. It's at the bottom here somewhere, this one. So we're going to calculate the deviations from the mean in the x values, in the y values, then multiply them together, then add all those up for each data pair, and then divide by the sum of the squares of the x values. All right, so let's keep that in mind. So first of all, we need the mean x value. So yellow cells I use to reference sort of given information, green important calculations that we're going to do. So I want to calculate the mean. That's simply an average. So it has, Excel has built-in functions for these common functions. Select all the numbers I want to average, close the bracket, boom. Now this one should also be green. I'm going to calculate a mean for the y values as well. So let's pretend I don't know what the function names are. I can go up here and insert a function and then search. Well, I need a descriptive word. Average is a good description of what I'm looking for. Go. Let's suppose you didn't know, I want to calculate a mean. You have to look at the descriptions and say, oh, the average, the arithmetic mean, yeah, that's exactly what I'm looking for. So my y values are there. Select them all, say OK, boom. And you see it did the exact same thing. So if I reference my formula again, which you don't have to memorize, you should have a formula sheet of some kind available. I want to calculate the deviations in both cases. Okay, so let's calculate the deviation. I start my calculation with an equal sign. I want to calculate the x value minus the mean deviation. And I can copy that down. I don't have to do it one by one. I have that luxury here. Now you can copy and paste, or you can just hover over the right bottom corner there and drag it down. But you see, it didn't quite do what I want. It's using the correct x value, which sits next to where I'm calculating, but the mean is not pink where it should be. So I can go back to the original and say, I want to fix that pink cell to not move with me when I copy this down. So I put my cursor inside and press F4, and the dollar signs indicate that it is fixed. Now when I drag this down, double click, yes, okay, it's using the cell which happens to be the same x value. And it is, oopsie, I lost my colors, and it is still referencing the pink cell as it should. Now I have the confidence to drag it down for all the others and check a random one. Beautiful. I also want to do the same thing for the y values. So I can copy this calculation essentially and paste it in. Double check it. It's not really doing exactly what I want. It is referencing the y value correctly, but it's still using the mean of the x values. So I'll just move that over, and you see it's still fixed. Then I'm going to copy that down in the same way, check a random one, and yeah, okay, it's doing the right things. Good. Now I will check. What are we looking for again? Well, deviations. So we could calculate the numerator right now by looking at the product of these deviations. So I'll start my calculation, multiply the x deviation with the y deviation. Copy that down in exactly the same way, check a random one. Yeah, beautiful. It's doing the right things. That's only the numerator. So we can, I'll just copy the word sum here to remind myself what the sum is. Maybe that's an important green cell that I want to highlight. I want to add them all up. So there's a built-in function, the sum function. Pretty descriptive, so that one's an easy one to guess. and I want to add those up. But that's just the numerator, right? To calculate the b, which is the coefficient of my input variable, my x variable. It's the slope, if you will. So now I want to calculate, I need to divide that by the sum of the squares for the x variable. So for that, I need the square deviations, sum of the squares of the x variable. So I need to simply square these deviations. So I take that cell, square it, and there we go. Copy that down. Check a random one. Yeah, it just squared it. Beautiful. Now I do want to add these together because that's what this SSX means, sum of the squares. So I'm going to put in, maybe that should be green again. Stand out from the others. I'm going to calculate the sum of all these square deviations. Remember to close your bracket, and there we go. So now we can calculate the b as the formula suggests. We've already calculated the numerator over here. We're simply gonna, oh, that should be green too. We're simply gonna divide them by the sum of the square deviations in the x values. There we go. Okay, so the b is done. In my, remember my predictor is, there's lots of ways you can write this, I suppose. How should we write it in the most convenient way here? Well, let's just write a plus, maybe some spaces, plus b times x. One more spaces. Okay, so b is the coefficient of x that we now calculated. I have to calculate the a, and the formula is here on the next page. The mean y value minus b times the mean of the x values. So in this case, I didn't need these, but I think I had them from the correlation coefficient example we did previously. So what did I say? Mean of the y values, so reference the mean of the y values, minus b times the mean of the x values. B is over there, times mean of the x values. There we go, 9.565, sorry. And then the question wants us to calculate the predicted anxiety score from these three different dexterity scores. So, using my formula here for the prediction, rule is the a value, which I'm going to fix because I'm going to copy it later, plus the b, which I'm also going to fix, times this x value. And we get a predicted anxiety score of just above 8. I can copy this down, and you see that, yes, doing the exact correct thing, keeping those a and b, which are always there, but using the new input criterion variable value. And so for these different dexterity scores, I get predicted anxiety scores, which I'll obviously have to round to see. Depends on the scale of my anxiety scores, which in this case I think went 0 to 10, something like that. So let's just remind ourselves, what page was this on? 535. 535. We're looking for the linear prediction rule, which we now have. We calculated the prediction for 3 different dexterity scores. Don't we visualize it? Oh, that wasn't B. Yeah, no, I missed it. No. We calculated the prediction rule. We went ahead and used it, but we didn't draw it yet. So let's maybe draw it now. So you're drawing the prediction rule, which is just a straight line using these two values. Now you can totally do that. It's a little clumsy in Excel to draw a straight line, but you can actually click on any of these points, right click, and go to add trend line, and it's going to fit this through for me. The least squares fit. And if I go to the options at the bottom here and I say display the equation, I can see that it is that negative 0.152, sorry, negative 1.52, as well as the 9.652. So I can cheat a little bit and draw the straight line through these points by clicking on it and add trend line. A little bit of a cheat, but we're doing the spreadsheet for convenience after all. Lastly, we want to calculate the standardized regression coefficient. That, oh, I didn't have a page number for that. That's unfortunate. What page is that on? Well, the other formulas were on page 506. So I think this might be 506. Oh no, where is it now? I'm going to scroll real fast. Where is it? I am so unprepared. I know it's coming. I know it's coming. There it is. So the formula here for the standardized regression coefficient, which in the one variable criterion case is the same as the correlation coefficient, is B times, let's start the calculation, B's over there, boop, times a square root. And square root will be SQRT. First thing I want in the square root is the sum of the squares of x. But we have that over here. Sum of the square deviations. So I'm going to reference that cell. And now I see, ooh, I didn't do the square deviations of the y variable. So, okay, I'll just keep what I have here and press enter. I know that's not the right number. And let's go back here and calculate it for y as well. Just copy the formula that is sort of right over to the y column or the y side. And I see, yeah, that's actually perfect in this case because it's just the sum of the square deviations. Copy that down. And I also want to add these together, but that's exactly the same as this one. So instead of typing everything, I'll just copy and paste. And there we go. Sum of the square deviations of y. Now I can come back here and continue my, no, I lost my colors. Continue my calculation where I have to divide by the sum of squares of the y's. So square root, sum of the square deviations for y, and there we go. And then usually the one that is interpreted mostly is r squared. So this is, in our case, equal to the correlation coefficient. When I square it, take that guy and square it. Not there. Redo. There we go. There, I want to start a formula. Take that one and square it. And then I get an indication of the proportion of the variance that's accounted for by the predictor variable. So how much variation in y is accounted for by x changing as well. All right, so there is an example using the convenience of spreadsheets to just practice and lay out my information in a more convenient way. That's it for this example. Until next time.